Hello there guys, welcome back to another video. Now this is the end of year exam that you sat. Now make sure that we have our paper pen ready. We're going to fully paper pen any working out, any calculations, any explanation as well. So we need to make sure that we fixed the stuff we got wrong. So this way in the future we can get the same question or similar question correct. Now those kind of questions eventually next year they're going to be split into paper 1, paper 2. So the more practice you do and the more you fix your work, so in the future this should be easy in this case. Now first of all we have Hooke's law. Okay, now Hooke's law, it needs to, so first of all we need the graph to obey Hooke's law, so that's all we need. Now first of all we're going to plot the graph. Now we've got two axes, we're going to plot the graph. Now the one we did was force on the x-axis, the unit for force is Newton, so I'll put it there as well. The x-axis extension, okay, and the unit is meters. Now, for this to obey Hooke's law, if you remember, it needs to be a straight line. Okay, so this here obeys, it's a straight line, so this here obeys Hooke's law. So write down obeys Hooke's law. Okay, now Hooke's law states that as the extension increases, okay, sorry, let me just rephrase this. Hooke's law states that the extension and the force, they are directly proportional. So the extension is directly proportional to the force so long we are within the limit. Now if you want to get 3 marks, this is enough. This is enough to get 3 marks because this is the graph that shows it is obeying Hooke's law. Okay, now however we can go an extra step. So we can say at this point, doesn't matter what this point is, I'll call it x. So this point is the limit, okay, of, let's say, proportionality. Now what happens after the limit? Now after the limit we know if we're going beyond the limit, then a small force is enough to make it extend even further. So a small force is enough to make it extend further. Now this graph only works if force is on the y-axis, yeah, because a small force is enough. So here a small force is enough to make it go longer. So think of a chewing gum, for example. You have a chewing gum, you extend it, you keep extending it, a small force is enough to make it go longer. Okay, now remember the graph just needs you to obey Hooke's law. So the limit, you don't need to put the limit, but we're putting the limit now because we want to understand a little bit extra. So therefore this is beyond the limit. So we've got the limit, the dot, beyond the limit. So make sure that we fix this up properly, yeah. Now next one we have this here, we've got the resultant force. Now of course we can see that this here is much bigger, so therefore the object is going to spring up, so therefore we're going to say the direction is already going to be up. Okay, fair enough. Now resultant force is going to be 3.2, take away 2, this is just basic maths, it's going to be 1.2. okay, nothing crazy going on there, basic maths. Now next one, so here we need to remember this. What we have is we have the mass. Okay, so we have m. The question wants us to calculate the acceleration, so we have a. And then we've calculated the resultant force, therefore we have F. So therefore we need F is equal to m times A. That's the equation. Second, we're going to rearrange it, so A is equal to force over mass. Done. Now the force is what we've calculated already. It is 1.2 divided by 0.2. And this will give us our answer straight away, 6. I'll put 6 there. Done. 3 marks, yeah? Equation, rearrangement, substitution, and then if you did properly, the answer will automatically be there. Okay, now this one, I believe this question was similar from your summative, so if you did provide your summative properly as set, then you'll be sorted out. Now first of all, what we have the magnitude of the acceleration. What happened to the acceleration? The instant the object is released until the first time the object returns to its rest. Now the object, what is it doing? First of all, we want to understand. Let's go up. Now first of all, it is pulling it down. It's pulling it down and then releasing it. Okay, so first of all, now this one, what I'll do, let me just pause a little bit. Alright, so what I'm going to do is I'm going to put the link. So I'm going to put the summative in the link in the description, so therefore you can go and watch this one. So it is at 6 minutes 30 seconds. Again, so this we already went through that during the summative part, so feel free to fix yourself. Okay, let's keep on going. This one, let me have a quick check as well. Okay, question 2 also is from your summative. I just saw that, and again I'll put the links in the description below. So this starts at about 14 minutes dot 38 again, so I'm not going to go through that again, so you should know. So acceleration is using the gradient. Okay, distance travel, the area under the graph. Okay, so you should know this already, and the motions also in the summative. Let me check. Okay, so pretty much question 2 is entirely there. Alright, so now let's go to the next question. We've got question 3 in this case. Now let me check again if it is in the summative or not. Question 3. Okay, question 3 is also in your summative. So this was also in summative. Again, I'll put the description below. So this was about 10 minutes 22 seconds again. So you can actually see if you revise your summative. So question 1, you have gotten full marks. So if you've revised your summative, if you improve on it properly, okay, then you know that this is the same question. You should be able to get full marks there. Question 2, again, you revise your summative. We did pop a pen on that. If you know this properly, then if you did your pop pen properly, then you would have gotten full marks. Number 3, again summative, so you would have gotten full marks. So pretty much in theory, if you did your pop pen properly in summative, you've gotten yourself 6 marks. Okay, so 6 marks plus 12 already, so plus 12 marks. Okay, plus 12 marks and plus 11 marks as well. Alright, so this by default will give you 29 marks already. So 29 marks if you know your summative, you revise properly. Okay, and you did open your summative as well. Now let's say in the explanation you may lose, let's say you're going to lose, I don't know, let's say you lose 4 marks, yeah? So 29 take your 4, that's still 25 marks. Okay, so if you did this properly, you've still gotten yourself 25 marks. Okay, right, so this is why your power pen is important. So when you're doing it, you need to pay attention to yourself, because this is for you, this is for yourself. Okay, now let's keep on going. And what do we have here? We have question 4, which is also from your summative. This has also been submitted. Now we have 29 marks from before, okay, plus 4 marks. So plus 4 marks. So this will bring us to what? 33 marks if you've revised your summative properly. If you really pop up in your summative as you should have done, you've improved upon it, you revise it, okay, when you're getting ready. So 33 marks. So this will have given you like the paper is out of what? 82 marks. So the paper is out of 82 marks, yeah? So 33. So this, pretty much this, if you just revise your summative so far, this would have given you about 40%. 40% you'd be banked, yeah? And everything else would just be a plus. Okay, so 33 marks, wow. Summative from the summative so far. Okay, so again, so I'll put the link to the summative below, and this is going to be at the start of the summative, so 0.16 seconds. Again, so make sure that we fix this up. I'm not going to go over it because already in the summative we did go over this in the past. Now, this one was not in your summative, so we're going to be looking at this one. First of all, we're going to get 2 marks if we labeled how they orbit the Mars. Now we know it's telling us that the orbit of Vikings was the same orbit as the moon. Now, the moon of the orbit, we know it is almost circular. Now, how do we know this? We know this from our astronomy topic where we revised. So what we have is we have in the middle, we have Mars. I'm going to label it Mars, and then we're going to have the Viking going around. Now we need to show that it's going around in a circular pattern. Okay, so almost circular. Doesn't need to be perfectly circular, almost circular. So therefore, our Viking will be here. Now the Viking is a spacecraft. Doesn't matter what spacecraft is. I'm just gonna do a here Viking. So call it V2 Viking. It's going around. Now I've labeled the diagram Viking 2. I've labeled the Mars. Good. Okay. Now where are we going to get the points from? That is the question. Where are we going to get the points from in this case? Okay. Viking 2. So we get the marks if it's circular, so circular orbit. That's one mark. If Mars has been labeled is at the center, we can clearly see it is at the center of this. So this is 2 marks backed. Therefore, we're going to move the next one. Next one, draw a labeled arrow to the diagram to the force that causes it. Okay, that causes it. So we know that there'll be a force from the center of Viking. Okay, and this will go down. Here. And this is the one. Okay, so this is the one. So we're going to draw an arrow towards Mars, and the line of action must go through the Vikings. The Vikings in this case. Okay. Now this here, we're going to call this. It is the gravitational force of gravity. We just put gravity there. Okay. Now it is gravity from Mars. Mars is putting it toward itself. Okay. So Mars is putting it toward itself. Because gravity. Yeah. Now, some people say centripetal force. Now, centripetal force. Centripetal. It is the resultant force. And in this case, it is caused because the question says, how is it caused? It is caused by the gravitational pull of Mars. Now, we can say gravity because the Mars can allow gravity, or we can say gravitational pull. Now, we need to say the cause if we want to get these 2 marks, and then it needs to be through. It needs to pass through Viking 2, or pretty much, through it, inside of it. Okay. Okay, good. Now we need to link the equation. Now look at this. Look. I'll show you a trick here. I'll show you a trick. Pay attention to this trick. How do we know how the equation will look like? Now, what is the first? So let's first of all we have weight. Number 1. We got 2 mass. We got gravitational field G3. Now look at this. So most of the equation you'll come up with, the first one, you write number 1. After the first one, you say equal to. The second one and the third one, everything else will be multiplied. Everything will be multiplied. You can try this again. You can try this. Okay, I guarantee you most of the time, probably 80 or 90%, is going to be like this. Therefore, we have W, which is weight, is equal to mass times gravity, and this one mark. Now, this one we need to work on the mass. We need to rearrange. So M is equal to W over G. Now, weight. What's the weight? What's the weight? It's given to you here. So 2.1 times 10 to the power 3. We need to convert. Divided by 3.7, and this will give us an answer. Again, I'm going to round it up, so this will give me an answer of this one. Okay, so this is my answer in this case. Fair enough. Again, so make sure that we know where we messed up, yeah, because very interesting. Now here we have, why is the gravitational field strength on the surface less? Now, first of all, the reason why it is less is because Mars has less mass than Earth. Okay, all right. That's it. That's it. That's it. Okay. Okay. Now the size does not equal to the gravity. Okay. Now why is that? Because we have a black hole. So I take a black hole, very equal to extremely small, equal to very high gravity. Yeah. So if you think something small has less gravity, it is incorrect, because black hole by default it is extremely small, and yet it has the highest gravity. Okay, so we want to be careful there. The reason why Mars has a less gravity is because it has less mass. Okay, you have less mass, so therefore you have less gravity. Okay, the Earth is the Earth has more mass than you, so that's why you feel the Earth's gravity more. If you were to be more massive than the Earth, then of course the Earth will feel your gravity more in this case. Okay, now let's keep on going. What do we have here? Now this is efficiency. We need to remember the equation. Now efficiency, how efficient you are. This is the equation which you need to remember. Okay, so first of all, if you want to check your efficiency, first of all, how useful are you? Okay, divided by the total energy, because you're gonna have a certain amount. You have a certain amount of energy. The total energy that goes that you body put that you put into your body, and how much of that total energy are you using usefully? Okay, so first of all, useful energy. Where is it? Okay, so efficient. Oh, so we know the efficiency, and the air and the boiling tube gains this much energy in this process. So therefore, 1800 is the useful energy. Total energy, we have no idea. This will equal to 16%, which is 0.6. So therefore, I need to work out the total energy. So the total energy is equal to 1800 divided by this, and this will give me 112. So therefore, the total energy that is going, total energy first is this much. Okay. Okay. Now we need to work out the waste. Waste energy is equal to the total energy take away the useful, because this is what total is. The total is 11250 take away 1800, and this will give me my answer to be again. There we go. So this is my answer there. Again, you need to remember the equation for efficiency. You need to calculate the total energy first, and then lastly wasted, and you've done 4 marks. Again, you need to make sure that we get everything correctly. Now, I'll give 2 ways in which we can improve this efficiency. Now, look at this. Now, first of all, we got the beaker, we got the hot water. So what we want to do, first of all, because the water is hot, the water is going to lose energy to the surrounding. Okay. So what we're going to do is we're going to make sure that we insulate the whole thing. So therefore, this thing is insulated. Okay. Now, if you remember, way back in year 9, we did an experiment on this, so we're going to insulate it. So first of all, we're going to say wrap the beaker with insulation. That's the first bullet point. That's the first mark. Now, second mark, what can we do? Of course, let's take a look. Let's go back up. Okay, what is the second thing that we can do? Okay, now also we notice that there's a big gap from here to here. There's a big gap. Okay, so what we can do, we can also cover this part here. We can use a lid. Okay, secondly, I'm going to say cover top of beaker. Okay. Now, of course, we can keep on going if you want to do that. We can use like a different kind of